Okay, am I audible? Am I audible? There is maybe a network problem from my side. Okay, sorry for that. Okay, ask everyone to join quickly so that we can start. We can resume that, not start actually. So we are in the middle of super elevation, right? Okay, let me try again by sharing my screen whether it is possible or not. Let me check. Please hold on. Okay, now it's working right. Is it visible right now? I think now it's visible, right? My screen is visible or not? Please do respond. Okay, take it. Fine. So we'll not wait further. So let's go to the super elevation part. So these things we have already mentioned that what is super elevation. So I'll just first of all show you a diagram so that we can understand. Okay, even in this diagram, you can see this is a train. Okay, this is a cross section of a train. Okay, moving along a curved track. Fine, fine. So this is a central line of the train. Fine, this is a center of gravity of the particular train, and when a particular train move along a curve, basically, okay, now before that, this is a rail, inner rail, this is your outer rail, and this is a force acting on the inner rail. Here you can say force acting on the outer rail. Fine. Now here you can see it is little bit inclined to the inner direction. Okay, if you draw a horizontal like that, you can see, if you draw horizontal like that, you can see this inner rail is raised, sorry, this outer rail is raised with some amount from this inner rail. Okay, here you can see the super elevation amount. Here you can see this orange color line. This is your super elevation. Okay, by definition, what is super elevation? I'm not going to show you now. Super elevation, it is the difference in height between the outer rail and inner rail on curve. It is provided by gradually rising the outer rail above the level of the inner rail. Even in the diagram you can see it is the amount by which super elevation is defined as the amount or elevation or height by which a outer rail is raised would refer to the inner rail. And by doing that, what we can achieve? We can achieve this resultant force, okay, which directly acting on the outer rail. Fine. And we also get one resultant in or resultant of weight in inner direction, which can act in opposite of centrifugal force. You know the centrifugal force is acting in this direction, in outer direction. Try to take the train in outer direction. Fine. So to counteract this super elevation, we have to provide this super elevation. To counteract this centrifugal force, we need to provide this super elevation. By doing that, we can achieve a resultant force here, W you can see, which directly act on this outer rail. And also we have a horizontal component of weight, which directly, you can say, counteract or resist this centrifugal force. Fine. So our main idea to resist this centrifugal force. Fine. If you go again in deeper knowledge about super elevation, you can have this diagram. You can have this diagram. Wait, this particular thing. Whenever, suppose this particular man is trying to rotate this particular ball, which is attached with a thread. Okay, and it is trying to moving around it. Now, in a particular situation, what the forces are acting on that? Basically, two forces mainly act. One is your centrifugal force, is try to take out the ball in outer direction. That means if you cut this thread here anywhere, the ball will go outside. Okay, and there is a tangential force will also act. Okay, tangential to the circle, and to resist this centrifugal force, one force will also act, which is called centrifugal force, which is directed to the center of the circle. Okay, So when it comes to acceleration, in terms of acceleration, that means your change in velocity with respect to time. Okay, so if it comes to that acceleration, wait. Okay, so yeah, so here you can see which is tangential to the circle. The particular acceleration is known as tangential acceleration, and it is given by this radius of the circle multiply the dw by dt. W is actually omega. That is your angular velocity. Change in velocity, change in angular velocity with respect to time, multiply the radius, you can get tangential acceleration. And the radial acceleration, but basically in a along this direction. Okay, along the center of this, it will be your radial acceleration, which is denoted by v square by r. Okay, this is a basic physics about circular movement. Okay, the same thing will act in um, highway or in railway also. Okay, fine. Yeah. So yeah, this superillusion, it is about superillusion. It is, I think it is clear, right? And yeah, about the main function of superillusion that we have already discussed about that. Fine. Equilibrium speed, basically it is what? When this centrifugal force is balanced by super elevation. I'm talking about this. Okay. When this centrifugal force is balanced by the super elevation. Okay. In that place, what the speed of the train, the desirable speed of the train along our circular curve to normalize the centrifugal force by the super elevation. That is your equilibrium speed of train. Okay, that is your equilibrium speed of train. Fine. The equilibrium speed is the speed at which the effect of centrifugal force is completely balanced by this cant provided. Cant or superelevation are same. Okay. Now we're going to discuss about cant deficiency and cant excess. Basically, cant deficiency is what? Deficiency means what? There is a cant is provided less. It's called deficiency. You know, these things are, I think this is a basic English. Cant excess means what? Superillusion is provided more than it required. Okay. Cant deficiency means cant is provided less than it required. Okay. This is the main basic idea. Now, cant deficiency occur when a train travel around a curve at a speed higher than the equilibrium speed. Now, about equilibrium speed, we already discussed what is equilibrium speed. It is a speed of a train, okay, at which the effect of centrifugal force is normalized by the superelevation. Okay. Now, if the train achieve a speed which is more than equilibrium speed in that particular case, the superelevation, the required superelevation will be higher, but existing superelevation is little less. So we can say there is a cant deficiency, or you can say superelevation deficiency. So basically, it is denoted by cant deficiency only. So cant deficiency occurs when a train travels around a curve at a speed higher than equilibrium speed. Excuse me. Okay, and it is the difference between the theoretical cant required for such speed and the actual cant provided. That means if you are moving a train at a speed which is more than the equilibrium speed, then the required superevolution will not be there actually. Okay, but in that particular case, you can say there is a cant deficiency. We require more cant. We require more superevolution to overcome or to act, or we can, so that we can neutralize the centrifugal force. Okay. In that case, we have a cant deficiency. Correct. So basically, the cant deficiency is the difference in the theoretical cant required for that such high speed, which is higher than equilibrium speed, and the actual cant provided. The cant deficiency should not be more than 75 mm for broad gauge and 50 mm for meter gauge. So depending on the gauge, that is whether it is meter gauge or broad gauge, the allowable cant deficiency is vary. Okay. Maximum permissible speed. There also a very basic definition of maximum permissible speed. So it is the height speed permitted to a train on a curve, taking into consideration the radius of the curvature, actual can deficiency, can access, and length of transition. That means considering all these factors, the maximum, the peak speed that can a train can achieve. This is your maximum permissible speed. That means if you increase the speed of the train more than this particular value, that means the maximum permissible speed, then there is a chance of derailment or overturning of the train. That means this is a maximum value that can be achieved by the train when moving along a curve. Considering all these factors like radius of the curvature, the actual can deficiency or can access, all these things, even the length of the transition curve. Okay, length of transition curve is also very important because along the transition curve only this superillusion, the the amount of superillusion is going to be implemented on the circular curve gradually. Okay, next can access. These things are again similar to that can deficiency, just little different. Like it occurs when a train moves around a curve at a speed lower than the equilibrium speed. Okay, that means a particular railway track is designed for a particular speed. Now, if you're moving a train lower than equilibrium speed, that means you can say the whatever superillusion provided, it's provided in excess. It is not required, but still it's given. That means we can say there is a situation of can't access. So here in that case, we can say a can't access, it is the difference between the actual can provided and theoretical can required for its low speed. It's a little bit just the opposite of can't deficiency. Can access is opposite of can access. Okay, fine. Next, can gradient, or you can say can deficiency gradient. What is that? So basically, this parameter indicates the increase or decrease of cant or superelevation along a transition curve. So we already discussed that the main purpose of transition curve is what? To introduce gradient and superelevation and curvature of that curve gradually from straight to curve. Fine. So basic idea about transition curve, this is already discussed with you. Now, this super elevation is also introduced even in the transition curve itself, but it is gradually increasing. That means if I show you as just simple diagram, suppose this is straight curve, okay, okay. Now at particular turn, the maximum super elevation is should be up to this, right? Okay. Now there is a gradual increase of super elevation. Okay, that means suppose this is a transition curve, okay, and from suppose this is your straight curve. This is a straight curve. From straight curve, we need to go for transition curve. Now transition curve is going just showing a different. Um, this is suppose this is your circular curve. This is your transition curve. Okay. Now this is like that. So it means suppose this is your super elevation, or you can say the rail. This is your inner rail. This is your outer rail. Fine. Just to understand, fine these things. I'm showing this. That means this much amount of super elevation, or you can say rise of the outer rail, should be provided with respect to inner rail. Okay. It is not directly provided from the straight curve. It should be provided gradually. And how can we provide gradual increase of superillusion? By introducing the transition curve. Along this transition curve, we can provide a gradual increase of gradient. You can say gradual increase of gradient. It also gradual increase of superillusion. Okay, so these things are done along the transition curve, and these things also known as Kant gradient, or you can say Kant deficiency gradient. Now, when it come like a Kant deficiency gradient of 1 in 1000, it means what? It means a Kant or a super elevation or a Kant deficiency is provided of amount 1 millimeter for each 1000 millimeter of transition line. Okay, that means for each 1000 millimeter length of transition curve, there is a gradual variation of your Kant of amount 1 millimeter, like that. Okay, fine. So rate of change of Kant deficiency. Yeah, these things are already included here. Rate means what? The application of or implication your application of Kant deficiency it should be gradually increase. Okay, that means this is the rate. That means the rate of change of can deficiency. Basically, this is the rate at which a can deficiency increases while passing over transition curve. Like, for example, a rate of 35 millimeter per second means what? That is, a vehicle will experience a change in can deficiency of 35 millimeter in each second of travel over a transition curve, traveling at a maximum permissible speed. Okay, that means with respect to time, the change of cant is called rate of change of can deficiency. Can deficiency. Okay, with respect to land, the change of can deficiency is called, basically it's generally can deficiency gradient. It's simple as that. Okay. Now basically what is super elevation or can, it is given by this formula gv square by gr. We are going to discuss about how it come anyway, don't worry. Okay, so super elevation is given by this equation gv square by gr, where g is your gauge length of the railway track, p is your speed of the vehicle, that means speed of the train in meter per second, and r is your radius of the curve. Okay, and small g is your acceleration due to gravity. Okay, now here you can see in this particular formula v is in meter per second. Okay, now if you write v in kilometer per hour, the particular same equation of superposition will go in like this, in this form g v square by 127 r. It's very important. Okay, in some exam this is asked. Gp square by gr, it is in meter per second. The speed of the train is meter per second, and if the speed of the train is in kilometer per hour, e becomes gp square by 127 r. Okay, and the maximum permissible super elevation for broad gauge is 165 millimeter. These things have to remember like this. Okay, now let's discuss about your negative super elevation. We have discussed till now about what is super elevation. These things you have already know. That is, what is super elevation? The when outer rail is raised by some amount with respect to inner rail, that is called your super elevation. Okay, but there is a term negative super elevation which is only applicable in train, or you can say railway engineering, not in highway engineering. Okay, this is only a parameter which is used, which is applicable in um, railway engineering. Okay, and in very some competitive exam or even in competitive exam viva, these things usually ask about negative super elevation. Okay, now it's very simple to understand, just concentrate here. On curve, the branch line meets the main line at certain place. Now what is branch line and main line, we're going to discuss in coming module. Anyway, I'm showing you a diagram. Here you can see, suppose this is a train coming in this direction and this is a main line. Okay, that means it's connecting, it is considered as a main line. Now there is a diversion provided from this main line. Okay, you can see the point in crossing. Basically this is all about your fourth module. So anyway, I'm not going in very detail about point and crossing, just concentrate here. This is your main line of the train and this is your diversion line, or you can say the branch line. Fine. Now as per the definition of superevolution, what do you know? The outer rail is raised above the inner rail. Okay, if you concentrate only in the main line, here you can see this is your outer rail of the main line, this is the inner rail of the main line. So when it comes to providing super elevation, this outer rail of the main line is raised above the inner rail of the main rail. Fine, but here you can see there is also a branch line directly in touch with the main line. That means for this branch line, this is the outer rail. Okay, and this is the inner rail. Fine. Anyway, now come to the here. Okay, so on curve, branch line meets the main line at certain place. The outer rail of the main line of the curve meets the inner rail of the branch line. Okay, now here you can see at this point. At this point, you can see at point A, here when from main line the branch line generate. Okay, at this point this line is represent outer rail of the main line. Same way this line represents inner rail for this branch line. Got it? So basically this is a very crucial point of a railway engineering. Okay, basically it is also known as a point. This is known as point, this is called crossing. That's why it's a combination of point and crossing. Fine. So on curve, okay, the outer rail of the main line of the curve meets the inner rail of the branch line. As the superelevation is provided on the main line, the outer rail of the main line is at the higher level than the inner rail. That means when we talk about the main line, here you can see this is outer rail. This outer rail is little bit higher in higher elevation compared to this inner rail. Fine. The inner rail of the branch line will have to keep at the higher level than the inner line. That means since the branch line originally it's a part of the main line. Okay, that means although although okay, please unmute yourself. Sorry, mute yourself. Mute करना सब लोग. Okay. See, although this represents the inner line of the branch line, but it is actually the part of the outer. Who is that? Jos Josnalin. Okay. So anyway, since this inner rail of the branch line originally it's a part of the outer rail of the main line. So by default we have to raise this outer rail of the main line compared to this inner rail of the main line. But this is the inner rail of the branch line. Okay, that means in this scenario if you only consider the branch line, here you can see in that case the outer rail, not the inner rail of the branch line is higher than the outer rail of the branch line. So here you can say this is a directly opposite of the basic idea about super elevation. In that place you can say there is a, that's why it's called opposite super elevation, or in other words you can say the negative super elevation. Got the idea of the negative super elevation? The inner rail of the branch line will have to be kept at the higher level than the inner rail. Okay, but here as the outer rail in the branch line is at the lower level than inner rail, the super elevation is known as negative super elevation. Okay, that means especially it occurs in point and crossing only, this negative super elevation. This negative super elevation is mainly applied in point and crossing. Okay, mainly in point when a branch line is diverted from main line. Fine. When inner rail of a branch line is originate from outer rail of the main line, and in this point the outer rail of the main line is raised because of the super elevation with respect to inner rail, but this super elevation is actually a negative super elevation for this branch line. Okay, clear? So these things are already explained here. We go through these notes, all these things are explained here. Okay, go through this. Now how to implement a negative super elevation, you just also go through this. We'll going to discuss in coming classes also if you can, if you have any doubt about that. Okay, like that. So with this I just want to conclude about super elevation. It is not finished yet. We're going to continue in the next class also. It is required little bit time also for super elevation. Next class also we're going to discuss about super elevation. Then after that we're going to discuss about some numerical on super elevation. Then finally we can come in the end of the third module. Then we'll very soon we'll start uh, that one, your next module. Fine. Anyway, I'll just show you once important images for you. Anyway, wait. Okay, so these things are already clear to you. Okay, let me check. So regarding centrifugal force, I think this is, you have already got these things in previous semester, even in the physics. Anyway, this is some information for your understanding. It is given here. The radial acceleration that we already discussed about that. Okay, this radial acceleration about that. This radial acceleration. This radial acceleration produce a centrifugal force which act in the radial direction away from the center. And the value of the centrifugal force is given by this formula. You know this formula, no? This it is mv square by r, isn't it? At least how it's come, it is like that. Force equal to mass into acceleration. You know these things. The force equal to mass means m. Acceleration is what? V square by r. Fine. M can be written as w by g. Okay. Where F is your centrifugal force in ton. W is the weight of the vehicle. In our case, it is the weight of the locomotive, or you can say the train. V is the speed in meter per second. Small g is the acceleration due to gravity, and r is the radius of the curve. Okay, when it comes to this image, you will see r is the radius of the curve. Okay, and because of this radial acceleration, it creates centrifugal force. Okay, this radial acceleration, it basically radial acceleration creates this centrifugal force. Okay, and we need to resist this centrifugal force by implementing super elevation. So these things are about centrifugal force. Okay, F is equal to m p square by r, or in other words, we can write w by g p square by r. Okay. Now, to counteract the effect of centrifugal force, the outer rail of the curve is elevated with respect to the inner rail by the amount which is equal to superelevation. This is already we have discussed. Okay. The main purpose of implementing superelevation is what? To counteract the centrifugal force. Okay. That means to resist this centrifugal force. Okay. Now, the state of equilibrium is reached when the both wheels exert equal pressure on the rail, and the superelevation is enough to bring the resultant of the centrifugal force and the force exerted by the weight of the vehicle at right angle to the plane of the top of the surface of the rail. In this state, of the equilibrium, the difference in the height of the outer rail and the inner rail of the curve is known as equilibrium superelevation. So basically, what is equilibrium superelevation? When a a state of equilibrium superelevation will reach when the both wheels exert equal pressure. First of all, I already told you that what is the main advantage of superelevation. By providing superelevation, we can distribute the load coming from the wheel to the rail evenly. Okay, so that the wheel pressure will be going on the rail will be equal. That means a state of equilibrium is reached when the both wheels exert equal pressure on the rail, and the superelevation is enough to bring the resultant of the centrifugal force and the force exerted by the weight of the vehicle at right angle. Now I will show you this diagram. Okay, you can see this the weight of the train. Okay, weight of the train, and this is the center of gravity, and this is your centrifugal force. It's directly uh, mutually in a right angle. Okay, this is a state of equilibrium superelevation. Okay, when the centrifugal force is perpendicular, or you can say in a right angle to the direction of the weight of the train, it is called superelevation. Okay, and basically this theta, or this theta, you can say this is your superelevation. Even this theta also you can say the superelevation. Fine. Okay. Okay. Now in this particular diagram, here you can see, you know what is tan theta? P by B. Okay, perpendicular by base. Okay. Now if you see, uh, let me check one more time. E by G. Okay. If you consider this theta, okay, if you consider this triangle, the below triangle, This is a theta. It is the slope at the inner rail. Okay, and the distance between this rail, outer rail and inner rail is known as what? Gauge. You know these things, right? Consider this is a base of the triangle. This is your perpendicular of the triangle, which is denoted by super elevation. Okay. Now, if you consider the tan theta of this from this triangle, it will be what? Perpendicular by base. Okay, tan theta will be perpendicular by base, and here perpendicular is what? Super elevation. And what is base? Your gauge. Okay, you can write tan theta equal to super elevation by gauge, P by B, E by G. Tan theta equal to E by G. Okay. In other word, we can also write tan theta equal to centrifugal force by W. Weight. How can? Consider this triangle, the bigger triangle. Even here also, the theta is angle generated at the center. Okay. Now, from this triangle, this is your perpendicular. This is the base. This base is given by the your weight. This is a direction for the weight, right? And this is your what? This is equivalent to the centrifugal force F. Okay. So we can write tan theta from this bigger triangle P by B. P means centrifugal force, by B means W. This is your weight. Okay. So we can write tan theta equal to centrifugal force by weight F by W. So we can see we can equate these two values, that is E by G equal F by W. E by G equal F by W. From this we can write E means what? E means your super elevation, right? F equal E equal F multiply capital G by W. Okay. Now what is F here? F is your centrifugal force. Now we already discussed what is centrifugal force. F is equal to W by G multiply V square by R, right? So in the place of F, we can write W by G into V square by R multiply by G by W. So finally, we'll get G V square by GR. So superevolution equal to G V square by GR. Here you can see, I have shown you, right? Superevolution is what? E equal to G V square by GR. Okay. So from this, you can derive also. Superevolution is what? G V square by GR. Where E is your superevolution, basically equilibrium superelevation. So what is capital G is the gauge length, that means the distance between inner rail and outer rail. V is your velocity, small g is your acceleration due to gravity, capital R is the radius of the curvature, and in the metric system, equilibrium superelevation is given by the formula. Okay, that means if you are writing V in kilometer per hour, you will have this G V square by 127 R. These things we have given here also. Okay, G V square by 127 R, and this is the explanation how it comes. Okay. Fine. So basically, this super elevation, uh, where a super elevation is in millimeter and v in the speed of a kilometer per hour, and r is the radius in meter, and g is the dynamic gauge in millimeter. That means in this particular value, in this particular formula. Okay, fine. And you know what is gauge length? It is the center to center distance between the rail. Okay, in millimeter. Fine. And this is equal to the 1750 millimeter for broad gauge, and for meter gauge is 10858. That means this value, this capital G, this is your, I think these things are already discussed in the module 1. For broad gauge, what is the gauge length, what is the gauge length for meter gauge, these things are already discussed with you, right? Yeah, these things are already discussed. Okay, so here I want to conclude my sharing. So in this class we have discussed about transition curve, we have discussed about super elevation also, right? So is there any doubt? If you don't have any doubt, then I just conclude my class here, and I will going to share all these things, so don't worry, we'll get these things. So go through the study. Fine. So next class we're going to discuss about some numerical, okay, related to super elevation. Fine. And then we can conclude the class. Yes or no? If you don't have any doubt, then I'll just take attendance, but you have to write first, yes or no. I'm stopping my recording here. Okay, I'm stopping my recording here, then I will take your attendance.